Recently, a viewer commented on one of my videos and he wrote, "I was under the impression that fully enclosing your pickups in a Faraday shield would prevent them from picking up the signal from your strings. Can you explain how you can allow for the magnetic signal from the strings to be picked up by the pickups while still shielding your pickups to prevent other signals from entering?" Seems counterintuitive, and many others have specifically stated that you can't completely shield off your pickups without stopping them from functioning. This is a very interesting question because we all know that guitar pickups can be covered or uncovered, yet they both work. That doesn't seem to make sense. Why is that? Well, to really understand, we have to understand how the pickups work. Now, since we're dealing with an electrical circuit, what I want to do is I want to separate the term signal. In my view, and for the sake of discussion in this video, a signal is the flow of electric current. That's important to understand, as you'll see here in a minute. But the way a pickup works is, on a guitar you have your strings, and when you pluck the string, it vibrates. Now the string is made out of steel and has a slight iron content. Therefore, it can be magnetized. Now the pickup is essentially a coil of copper wire on a bobbin. And in the case of a humbucker, you have two of them. There's a magnet, a bar magnet, that runs underneath the pickup, and it comes into contact with the pole pieces. One side is the south pole of the magnet, the other side is the north pole of the magnet. So these pole pieces are magnetized. This creates a magnetic field which surrounds the entire pickup. Since the steel strings pass through that magnetic field, when you pluck the string and it vibrates, that vibrational energy is then transferred to the magnetic field of the pickup. That's why we call it a pickup. It's picking up that vibration. The strings don't produce an electric signal. What they do is they vibrate, and you can measure vibration in a number of different ways, but in a guitar with a pickup, we measure that vibration in frequencies. Each string, because of its different diameter, vibrates at different frequencies. Those frequencies are then transmitted to the magnetic field that's surrounding the pickup, that's produced by the bar magnet and the magnetized pole pieces. So now we've got those vibrations from the string now affecting the magnetic field that surrounds the pickup. Whenever you distort or excite or vibrate a magnetic field, if there is a copper coil wire bobbin like this in the middle of that magnetic field, that'll cause the electrons that are stationary inside of that copper wire to start moving. That is your electrical signal. It doesn't matter whether the pickup is covered like this one or not covered like this one. It's going to pick up the vibrations from those strings. The only way that you could prevent the pickup from picking up those vibrations would be to move the strings far away from the magnetic field, outside of the magnetic field. Then it would have no effect, and the pickup would not be able to detect those frequencies of vibrations. So let me I'm going to show you a little demonstration that will show you what I'm talking about as far as the magnetic field is concerned. And I think that will help you to understand why a cover doesn't cut off or block or cover or smother that magnetic field. Okay, so what I have here is a Gauss meter, and a Gauss meter will measure the strength of the magnetic field. And this is the probe that measures that field. If I move the probe close to a humbucker pickup, as I get closer, you start to see the measurement increasing. The number is going up as I get closer to it. And that is true whether the pickup is uncovered or whether it's covered. The same thing happens. And the reason for that is because the magnetic field that is surrounding this pickup extends well beyond its shape. So when you put a cover over the pickup, the magnetic field is still there, and the strings are passing through that field. And when you pluck the string and it vibrates, those frequencies of vibration are transferred from the magnetized string into the magnetic poles of the pickup. And since the magnetic field surrounds our bobbin filled with thin copper wire, the electrons inside that copper wire begin to move, and that flow of electrons becomes a rather weak electrical signal. That signal then travels through the controls on the guitar, like the selector switch, the volume and tone pots, and then it goes to the jack, where it is then carried by the output cable to an amplifier. The amplifier then boosts the strength of that weak signal enough to where the speaker can convert it to sound that we hear with our ears. Hey guys, if you're enjoying this video, you can show your support by clicking the thumbs up button down below. It's free to do. You can also click the subscribe button, which is also free. And when you do that, you can click the bell for notifications. That way you'll never miss any future content. But if you want to take your support to the next level, you can click the thanks button and leave a tip in the amount that you think is fair. Or you can click the join button or the subscribe plus button and become a member of my channel. And as a member, you're going to be able to enjoy videos just like the one you're watching, but with much more detail, and best of all, no ads. Now let's get back to the video. So whether you put a cover on a pickup or not is not going to affect the pickup's ability to detect those vibrations. However, that doesn't mean the cover isn't going to affect the tone, because when you place a cover on a pickup, it can slightly change the shape of that magnetic field, and that will affect the tone. Anybody who has had a guitar with covered pickups knows that when you remove those covers, it can change the way it sounds. Now, some of that may be psychosomatic, but I've done it enough times to know that it is for real. Covering the pickups will slightly change the tone. However, it doesn't block the signal that's going out. It doesn't prevent the magnetic field from detecting the vibration of those strings when you put a cover on it. So I hope that makes sense. Now I should also talk about what it means to have your pickup enclosed in a Faraday cage. And a lot of people misunderstand what a Faraday cage is. A Faraday cage is designed to prevent electronics from being affected by electrical interference from other sources of electricity. For example, the lights in my shop and the lights I'm using to illuminate this video, they produce interference, electrical interference. You can't see it, you can't feel it, but if I plug in a guitar into my amplifier, turn it on, turn up the volume, maybe add a little bit of gain, you're going to start to hear that interference because all electrical sources produce it. By using shielded wire, shielding your cavities, and enclosing your pickups can help to reduce that effect. It blocks that electrical interference. But that interference is a different kind of signal than what we're generating when we pluck the guitar strings. The guitar strings are producing frequency vibrations. The lights in my shop and other electrical components, my computer, cell phone, recording equipment, that's producing electrical interference. It's an electrical signal and it's transferring through the air, and that's what's affecting the sound that you're hearing from your amplifier, because your wiring, your controls, your pickups, they're all acting like antennas and pulling in that electrical interference. However, by enclosing everything, as I said, by shielding your wiring, your cavities, and enclosing your pickups, you greatly reduce the amount of that electrical interference that's being absorbed by your guitar and then converted to sound in the speaker that's connected to your amplifier. Now, there is a little bit of a myth about how a Faraday cage works. Most people will assume that in an electric guitar, a Faraday cage has to completely enclose the pickup, almost as if it was an airtight seal. But that simply isn't true. If you look at large industrial equipment, you'll notice oftentimes, like big generators, will be placed in what is essentially a cage made of chain link. And that chain link is the Faraday cage. Even though you can stick your fingers through the chain link that surrounds it, or even squirt water, and air moves back and forth without any issue, electrical interference can't, because as it tries to pass through the openings in the links, it gets pulled into the links and is dissipated. And that's usually because the Faraday cage is grounded, so the interference gets sent to ground. So it's not a solid surface that's enclosing those components. Well, the same is true with an electric guitar. You could enclose your pickups or your control cavity cover with a metal mesh, like a copper mesh. And that would suffice to dissipate any sort of interference and prevent it from getting into your electrical signal. Now, in order for it to work properly, you have to calculate how tight that mesh needs to be in order to work properly, which of course takes a little bit of math. And since a lot of people don't want to do a lot of math, what they'll do instead is they'll just use a solid sheet of material that is suitable for shielding, such as an adhesive-backed copper shielding tape. And that works just fine. As long as your mesh isn't too big, it's not an issue. If it's too small, or if it's non-existent and it's solid, it'll work just fine. So that's why we use the adhesive-backed copper foil shielding or shielding paint to shield our electronics from outside interference, and it works just fine. I hope this all makes sense to you and explains why a covered pickup doesn't block the frequencies generated by the strings. It's a pretty simple concept, and I think once you understand what's going on, it all makes sense. At any rate, if you found this video useful, take just a second to stop what you're doing and move your cursor or your finger, or your pointer or whatever, and click that little thumbs up icon. Tell YouTube you like the video. That way my video gets served up to more people and helps to promote the channel. But it also tells YouTube what kind of videos you like to watch, so it will continue serving up videos based on what your interests are that you may not even know exist out there. And of course, if you want to take your support to the next level, you can do some of the things I mentioned earlier in the video. And as always, until the next episode, take care, stay safe, and I hope you'll be back for more of these guitar building videos.